Can you see that is it recording? Because yes, they had a problem with that. Is it recording? Good, okay, very good. So normally if I write a function, let's say sum, I would have to say somewhat, right? So if I'm adding two integers, it's going to say int I, comma, int j. And that's going to add two integers. If I want to write a program that's going to add 20 integers, I have to list 20 integers as the formal arguments. But in certain languages, let's say, for example, like Python, when I write a sum function, is a built-in sum function, I don't have to say how many arguments I'm passing in. I can pass as many as I want. So those of you that, how many of you know Python? Just again, just show me with a show of hands. How many do we have that know Python? Just one? Okay, 5, 6, 7. Okay, so in Python, you know, what can happen is when I write a function, I can have what are called args, and which are the arguments that I pass in, and I have something called quargs, keyword arguments. And if I have a variable and I sort of said this is an argument with an arbitrary number one, I would say, you know, sum, and then I would say star. Let me just write on this thing, see if I can do that. Let me get this. Is it going to work? I would say, no, it's not working. All right, I would say sum, and then I would say, give me a number of arguments, and I have to say how many, and I can just add it up. So the question is, how do you do that in C++? In other words, I want to be able to write programs that look like this. I want to be able to sum, you know, 1, 2, 3, for example, without, you know, there's 3 arguments here. It's going to give me 6. And here I want to sum, you know, 2. I'm going to get a 30, and I want any number of values, and it's going to print the correct sum. So how do we get that behavior in C++? Okay, does that, everybody understand that? Any questions about what, not how to do it, but what the requirement is, what the question is? Write a function said like sum, and for an arbitrary number of arguments so that it mimics what you can do in a language like Python.
Do we submit on Blackboard?
I will talk to your, who's the lab? Oh, yeah, we'll talk about that later on. We'll talk about that later on. I'll introduce you to the TAs and then tell you what they want to do. All right, so that's the first program. Here's the second one. I want you, well, I'm going to leave this for a while. Debug the queue. Let's say we do this one, number 2. So you are you're a interviewer at Google, and sometimes, right, they pull you away from your actual job, and then you have to ask some questions to see what people understand, what they don't understand, and so on. So one of your favorite questions is, show me some code segment that you think is interesting, right? So the candidate you're interviewing shows you the following thing. And you ask, why is this interesting? And she says, this is going to return true if n is either 0 or a power of 2. And you have to evaluate whether or not that's true or false. So is it true or false, and why? Right, that's what they show you, and you look at it and what's going on over here. Okay, so that is question number 2. Question number 3 is the following. Given a number n, some integer n, like 9,477,000, how many ones are there when you count 1, 2, 3, 4, 5, up to 9,477? Okay, so for example, there's a 1 in 1. When you get to 10, there's another 1, so you're going to count 2. And then when you get to 11, there's 2 more ones. So far you've encountered 4. And then 12 and 13 and 14, those add ones. So if you're going to count all the numbers from 1 up to whatever n you're being passed, you want to know how many ones you've encountered on the trip from 1 to n. Is that question clear? Yeah. Any questions about the questions? So these are due on Monday, and we'll tell you how to submit these. All right. Okay, so now let's get back to what we did yesterday. Let me bring up the other program.
One question I have for the homework. So do you want like comments and stuff?
Yeah, so we'll talk about that later on, because I have to talk to the TA and see what they want.
Okay.
And we'll get back to you. Okay, very good. All right. So let me go over here. So here is where we were. And we were looking at, the last thing we did yesterday is we looked at pointers. We did a lot of work with pointers. Is there any question about pointers and how they work and what they are and so on? Everybody understands what pointers are, right? So for example, you know, what's the idea is that someplace, every time you have something in memory, it occupies some specific piece of real estate. And just like when you walk down the street, every house has a house number. When you look at memory, so essentially every byte has an address, and you can address it. Now, depending on the the type of the memory object you're looking for. For example, if I say int I, so I'm saying that I is an integer, so that's going to be 4 bytes associated with that. But the address is going to be the address of the first byte that's assigned, that's associated with the integer variable I, right? We also saw when you do arithmetic, the arithmetic happens in chunks of the size of the type that you're dealing with. So, for example, if I have an integer array, as we saw, and we did this yesterday, right? Here's my integer array, and let's say a is pointing over here, and if I say a plus 1 is automatically going to be over there. In other words, it could be 4 bytes. If I declare my array to be an array of chars, how big is a character? Anybody? Characters, how many, like A, B, C, how big are the characters? The characters are 1 byte, and how big is a byte? Byte's 8 bits, right? And that's the smallest thing that you can actually address. So if this is a byte array, this is a character array, so A takes me to the first byte, and then A plus 1 takes me to the second byte. That's going to be important. We actually look at some memory allocation programs, right? So that's the idea. The arithmetic is in terms of the chunks. So the question that we didn't address yesterday is where in the world did this memory stuff come from? Where is it? Where is this memory? So again, I apologize to those of you that remember anything from 211, but we spent some time there. We're going to spend a lot of time here talking about, as I said, memory is fundamental to what goes on in C++ and pointers, and we'll look at how pointers are implemented in terms of smart pointers and memory management and so on, because if you understand that, you understand a lot about what's going on in the language. So what really happens, this is a schematic, and it's something like this happens, right? No matter what it is, it's something like this. So when you write a program and you pass it on to be compiled, it gets compiled, and if you have pieces of the program, you have a bunch of functions. The functions then go to something called a linker, and what the linker does is it links together all those various pieces to make one text file, essentially. It's not really a text file. It's the point that the linker happens. It's already on machine code, and then it gets loaded in, right? The loader then loads it in. The loader basically it gets a starting address in the real memory, and the whole thing gets put in memory at some starting location. And it's called a load module, right? So what it really looks like once it's in the memory is something like this. Again, I apologize for writing on glass, but that's what I got. So here is what the memory basically looks like. What that means is when your program's in memory, you get contiguous space, right? Contiguous. What is contiguous? Contiguous. What does contiguous mean? Contiguous means one next to the other. This whole thing is not chopped up in pieces at all. It's all these, space, right? And your program is given this whole piece of memory, and it's whatever it does, it's got to do in there. Okay. So what is this? So if you say int I, that I has to be located here someplace, right? If you have an array, that array has to be here someplace. If you have functions, those functions have to live here someplace, right? So where do they live? How does it look? So this is a schematic, but it's usually something like this. So this area that you're given, this load module, this piece that belongs to you when your program runs, is broken down conceptually into the following pieces. You have one thing over here. This is called the code segment. Also, I need you to tell me if I slow down. In other words, if there's a lag between when I speak and what I write, and you see. Let's see if that's why I have my video is off, and I'm seeing if it works. Anyway, what's in the code segment? As it says, code, right? So what does code mean? Code means all the code that's involved as your program is running. Where do you get code? What's some examples of code? Somebody talk to me. What's examples of code here? What's the obvious code? Remember, this is all binary related. This is machine language. When we talk about this, right? The machine language is all your program is running in the memory. Somebody, what do we mean by code? Well, obviously your program, right? That's code, right? Your main program, that's code. All the functions that you have in your program, that's code, right? What else is code? So any libraries, any library functions that you included. Let's say, for example, you said pound include IOStream, right? That's a library. So whatever you use from IOStream, that's going to be put together in one contiguous area, and that's going to be in the code segment, right? So whenever you run, so for example, I'm sure you know about the goto statement, or I think we did it in the, is it 240 or something, right? You have a, when you have a branch to something, so when you run a program, when you call a function, essentially what's going on internally is that there's a branch to the address where that particular code is. All the code lives in the code segment, right? All the rest, right? All the rest of that space is data of some kind. All this stuff here is data, stuff that gets manipulated or looked up and so on, right? So the code segment is one piece and the data is the other piece. Now, what kind of data is there? What kind of data is there? So why we talk about this? Because, what happens when you say int I? What happens if you get, memory, right? So at one point over here, you've got part of it. This is, again, all this, we're finished with the code. What we're talking about here is data, right? So one of the things you get here is a place specifically located for statics, for static, right? Static variables, or for globals, or for constants, right? That's stored constants, right? Those are stored in one particular area. So let's make sure we understand what these words mean. So for example, if I say integer I, right, in my program, is that a global variable or not? I need feedback, right? If I say in my program, if I say int I, is that a global variable or not? What is a global variable?
It depends where you
Depends
place it.
where it's
Right.
defined.
Right. Depends what?
Where in the code it's defined.
Exactly right. Right. A global variable is one that's globally accessible. In other words, it's defined outside of all the functions. Right. It's even defined. You have a file, right? And is it defined even outside the main? Yes. Right. If it's defined outside the main at the very top, let's say, so every variable, every function can actually utilize that particular variable. Those are called globals. Are globals good things or not? Should you use global variables or not?
Should not. Should
Not.
use it, yeah.
Not. Anybody say yes? Not? So if you say not, then why in the world does it include in the language? Why do they have these things called global variables? Well, like so much else in life, the answer really is it depends, right? What would be the problem? When you say not, what would be a problem using the global variable? What's the problem with it? Let's see what it looks like, right? Here's my here's my program. Program is in a file. It's a different picture than this one here, right? My program has statements, right? And here I have, let's say, integer main over here, integer main over here, and my program, and here I have some functions, function defined, function 1, function 2, and so on. And here I have int I equals whatever, right? Equals I have it over here, equals 10. Right, so it's this int I is global, right? Because it's outside all the function definition, including my main function. So what could be useful? Why is it possibly useful to have a variable like that? Why would I even want to think about that? Yeah.
So when you just say main calls function 1, they both have access to I, so main doesn't have to share that, doesn't have to create a variable and pass it on to F1 for it to be used in the function.
Right. In other words, it's good for shareability, right? That's very true, right? In other words, if I have a variable that I want to share between modules, between functions, right? By making it global, I can do that, right? Why would I want to do that? It's not really useful in terms of space. I mean, you don't have to worry about space today, right? You got tremendous, these machines, even your phone. These are machines with a lot of memory, for most programs that we're running. If they're not, you run on clusters and you run in the cloud. But it's good for what? For sharing information, right? So in other words, instead of passing information around from one function to the other explicitly, I can share it via some kind of, external variable, right? So, and then everybody has access to that variable, and I can look up stuff. Does that make sense? That's a good idea. Now, what's right? So that's nice, right? It's a nice idea that we all share, right? We can all imagine you have a blackboard, or you have a what do you call it? You have a whiteboard that it's accessible to everybody. Everybody can read it, and if you want to put up some kind of notice, you put it up on that whiteboard, right, or on the chalkboard, and everybody goes by and says, "Oh, that's what I was looking for," right? So that's pretty neat idea. What's bad about that? So that's a good idea, right? So what's a bad idea of a global variable? What's to be not liked? Sounds like a good idea.
It's hard to manage it because it can be altered at any part of the code, and sometimes it's just hard to manage.
What is management? You're right, but what does it mean by manage?
I guess I just mean like just pretty much keeping track of all the changes made to that variable at every part of the code. Like sometimes, yeah, that part might be hard. Just keeping track, I guess, is what I mean.
Yeah, right. Very good. Let me expand. That's a good idea. In other words, what's the most difficult part of writing code? It's not writing the code, right? It's making sure the code is correct. And when it runs and you get bugs, when you get errors, debugging takes, I don't know if we spoke about this yesterday, but debugging takes up most of the time when you do development. So if I have a variable that's shared and I get the wrong value in there, and I have 50 functions that have access to that variable, how in the world are you going to debug that? Right? Does that make sense to everybody? So while conceptually it's a nice idea to be able to have many functions share the same variable, it's a real terrible situation when you have to debug with it, right? So that's the downside. So if you want to compromise, when it is good to use global variables, it's when the global variable is a constant and it's used for lookup. Let's have a very big table, right? Like a big table, and many different functions have to have access to that table. So instead of either having copies of the table, in all the different functions, that's just a waste of space, right? Or passing the table around, or pointers to the table around, right? If everybody has access to the table itself, and I make sure the thing is constant, that's a good idea, right? So if I have to look stuff up and many functions have to have access, that's when it's mostly used, right? So those are global variables. We're going to talk about constants in a moment, right? What's a static? Does everybody know? Again, just by a show of hands, does everybody know what static is in C++? Let's do it the other way. Who does not know what static means in C++? Okay, everybody knows. Okay, good. Somebody tell me what static means in C++. So everybody knows. So what is static? Alex, Barian, what is static?
Isn't it that the variable gets space allocated only once at runtime, and then even if like you rename it, never gets a second space, it only gets one space at runtime?
Why does that matter?
I actually have no clue
Okay,
why it matters.
right. Anybody else? What's the idea of a static variable? Well, the idea is that you get it's allocated once. That is correct, right? But what does static mean? What does it mean? Like you put your socks in the dryer, right? And there's a lot of static. So what happens? They sort of cling to each other. They don't go away, right? They don't walk away if they're static, right? Usually socks tend to walk out of the dryer and you can't find them anymore. But if they're static, they sort of clump together. So that's what static means in C++. It's nothing to do with socks, right? But what static means in C++, so it has something like this. Let's say I have some function f. Okay, here's my function f, and I want to keep track within this function. Let's say void. Let's say it's a print function or whatever it is. Again, I'm all over the place here because this stuff keeps moving around. And I want to know how many times I have executed this function f, right? So it's very simple, right? All I do is I say int count. Give me a moment, guys. Not sure why this keeps happening. You guys still there, or did I lose you somehow?
We're still here.
Still here.
Well,
Still
I can't find you. Give me, oh, there you are. Okay, good. So let's go back. So I want to do the following. Wrong one. Right, so I have an integer variable. And what I'd like to do is I want to, it's called count. Right, count, and I initialize to 0. And every time I come back, I simply want to say count plus plus, right? And so the first time I come, it gets initialized, right? And then I count. So if I call this function 25 times, count will be 25, right? And I could say over here, cout count, right? Again, I apologize for the handwriting. So is this a good idea? Is this going to work? Is this a way of keeping track how many times I come into the function f? Clearly not. It's not going to work, right? Why not? Because every time I come into the function, I have to initialize it again, right? Does that make sense? And it's going to be every time it comes to be initialized to 0. So every time counts is going to be 1. It's not going to work. I can't use this to count how many times I've executed a function. But that's an important thing. You need to keep track of that, especially if you're debugging and so on. But in general, objects, classes, structs, sometimes you need to keep track of how many times they've been touched. So this doesn't work, right? Why is that, right? Because this variable has a scope. Everybody knows what a scope is. Scope is where the variable is known, right? So this variable, the scope of it is just in the function, and it comes to life when the function is entered, and it disappears when the function is exited. So this is not the way to do this. So C and C++ give you the ability to declare a function to be static. And I could say static, right? And say, just instead of saying int count I equals 0, I say static int count equals 0, right? And this is the initialization. And then later on, when I'm going to use it, I simply say count plus plus, right? And so the way this thing works, what static means is I'm going to store it in a special place, and here is the special place, as opposed to what places, what are the unspecial places, we'll see in a moment. But the static means I'm storing in a special place, and it's not going to disappear when I exit the scope. And this gets and the initialization happens one time. So the next time I enter the function f, this will be skipped. The initialization will be skipped, and I will say count plus plus, and that will answer my question, right? So it's sort of like a global variable, except for what? It's not really global. What does a global variable give me? It gives me persistence, right? No matter which function I call, it's there. It persists throughout the whole program, right? The static also persists, right? But it's not accessible by all the other functions in the the system I'm building. Is only accessible within the function itself, right? So sort of a static is sort of like a global variable, but it's limited in the scope to the function which is defined. Okay, does that make sense? Any questions? And it's very, very useful, right? So is it clearer now than it was before? I need you to say yes or no, because static is a very important idea. is it unclear to anybody? Is it clear to everybody?
Yep.
Yes, okay, very good, clear to everybody. All right, we'll see what const is in a moment, but you know what const basically is. Const says that this variable, let's talk about const a little bit. This const is more complicated than you would imagine, but what is const? Const means that the variable I'm declared is a constant. Constant means that it can't be changed. So one of the simplest uses of const is, let's say, for example, I say I have double pi is equal to 3.14, right? So if I, and I want to use, why would I want to use the variable pi instead of 3.14? Because one of the things you want to do in your array programs is really, you want to minimize the use of magic numbers. So if I'm doing some calculations and I say 3.14, so most people would know what that means, but if I have more, complicated, more esoteric constants or numbers that I'm using, people reading my code will have no idea. So I want to name those things, right? And say, pi times r, right? Instead of 3.14, right? That's the idea. The problem is if I just do it this way, there's nothing stopping me, in a fit of tiredness, or somebody changing, somebody who's modifying my program or updating my program to go down someplace and say, pi is equal to 19.3. And then everything else doesn't work, right? So what I can do is I can declare this variable pi to be a const. And I simply say const double pi equals 3.4. And then any attempt later on to change it won't work. Okay, the compiler won't let that. It's going to be flagged by compilers an error. It's going to stop the compilation. Okay, that's a const, but const means much more. But basically, and we'll see as we go along, but basically the idea is that certain things I have to write in my code. Don't let anybody change it. Okay, that's basically the idea. So that the statics, the globals, and the const, they get stored in some very specific place. Now, what about the rest? What's those things that aren't special? Well, they really are special, but they're handled in a very different way. So that is going to be handled in sort of three parts of the memory, right? There's going to be one part, and then this part over here is going to be broken up into two other parts. So this one part over here is called the runtime stack. Again, I hope that this is just a review for most of you. The runtime stack. When we finish this is exactly where I assumed that I was going to start the course, right? But if we don't go over this, then none of the rest of the course is going to make sense for at least 40% of the people. So this is called the runtime stack. And what's the runtime stack for? It's for automatic variables. Right, automatic variables. What is an automatic variable? What does that mean, an automatic variable? So it's a variable that is automatically allocated to you just by your declaring it, and it's going to be sort of taken back and disposed of automatically. Let me show you what that means, right? This sort of fancy talk for the following thing that you've been doing all along. So in a main program, right, I'm going to say something like, here's my main program. And then I'm going to say, you know what? I have an integer variable I. Now, all you're doing over here, if I ask you, what's the type of speech of this thing that says int I, right? What type of speech is it, right? So you're going to say, well, I know what the type of speech is. It is, it's a declaration, right? You're declaring I. When your program hits this, essentially, that's not really true. I'll tell you what's really true in a moment. You can imagine that this thing gets created. Now, where does it get created? It gets created on the stack. Now, everybody knows. You can't tell me no, right? You've all taken a data structures course, I hope, or at least know what a stack is, right? A stack grows. I have here's a stack, and then I can push onto the stack, right? I push onto the stack, and the next thing, and the next thing, and the next thing, and in the stack, the interesting thing is the only access I have is sort of like a linear structure, like an array. But an array, I can get to anything in the array. In a stack, I can only get to one specific place called the top of the stack, right? And when I put things on the stack, and I can't change anything in the stack, right? Everything happens on the top of the stack. So I can push on the stack, and then when I want to take something off the stack, I only have access to the stop, and I pop the stack, right? So when I extract something from the stack, take it off, it also gets taken off from the top of the stack, right? That's called, and so the runtime stack works like that. So the idea here is that I open a scope, right? A scope is where variables are going to be known, and then I do whatever I want. All of my stuff goes here, and then when I close it, when I come out of the block, right? A block determines what's a block. A block is something that's determined by the open curly bracket and close curly bracket. This block determines the scope, right? The scope being where things are known. So outside this block, I is not known because I haven't defined it yet. And at the end of the block, I is destroyed. Now, how does that work? So as it finds these variables, what's going to happen is as soon as it enters the block, it looks through this is a compiler. The compiler is going to scan through and see which of the variables are defined in the block. And so if I say int I, and down here I say like int j and so on, right? So then all of a sudden I is going to be on the block. Here's I. It gets put on the runtime stack. Now, what does it mean to say I gets put on the runtime stack? What does that mean? So what's the type? What is the type of I? Well, I is an integer. How big is an integer? And it's 4 bytes. So the compiler allocates space, or the equivalent thereof allocates space for I, which is 4 bytes. Right now, where does it get this? What does it mean? It allocates. It takes it from its pocket. Where does it get it from? So basically, this area over here, right, this runtime stack is basically given. That's the space for these automatic variables. And every time, and there's a little pointer to the top of the stack, right? There's a pointer that's top of the stack. So what's going to happen is, if I say I have an integer variable, so there'll be so I will essentially refer to that particular address, right? And then the top of the stack is going to be moved, and it's going to say, well, here's where I can put the next thing. If I have a double, so the compiler, of course, knows that a double is going to be 8 bytes. It's going to allocate the next 8 bytes. Now, what does it mean allocate? It's going to say, okay, this belongs now to the double called X, right? And then the top of the stack is going to be over there, right? It doesn't take the space from someplace else, and plug in a new memory module, right? It's really a stack that is going to be governed by these pointers, right? That's what happens here. And when does it do this? It does this as soon as the block is entered. So all of these variables that are in the block are going to be allocated space, and essentially any reference to them is going to be the address, because this is happening at runtime. But initializations in most compilers, if I initialize it, if I say, for example, int j is equal to 20, right? But I do that, let's say, down someplace in the program, right? So even though, you know what I'm saying, in other words, here I have the initialization of the declaration of I, and I got some stuff over here, and then I say int j, right? Int j is over here. Int j, and then here I say I initialize it, let's say to 10, but somehow I jump over this somehow. Let's say I have a go-to statement or something jumps over it, right? So the initialization generally in most compilers is not going to happen until the function, until this statement is actually encountered, right? Which if you remember what a go-to statements are, these unconditional branches, I'm not allowed to. The compiler will flag that as an error if I jump over initializations. It'll know about the variable j at the very beginning. It'll allocate space for it, but it won't initialize it until it actually sees, till the flow sees that initialization. And so the rule is that you're not allowed to do that. You can't jump over go-tos, for example. You can't jump over initialization. And what's the reason? Can anybody tell me why? Everybody remember what go-tos are? You can label statements, right? You can give a statement a label, and you can branch to it. Those are called go-tos, and they're useful in certain contexts, even though you have to be very careful. They can be very, very harmful. But the rule is you can't branch over the initializations. You can branch over declarations, but not initializations. And the reason is because uninitialized variables can be very, very dangerous. right? And those, because the variable will be known, the compiler will have known about them because it allocates a space for them at the beginning. But if you jump over the initialization with something to go to, then and you use that variable, it can lead to situations where you get errors and it's almost impossible to debug that, right? So that's just something to know. But anyway, so that's how this thing works, right? So every time you declare within a block, you declare variables, they go onto the runtime stack. Now, what happens when you exit over here? The stack gets popped. It knows how big this is, and it just pops it. Now, what is pop? Pop does not mean it, goes in there, the runtime goes in there with a screwdriver and pulls out the memory chip. All it means is that the pointer to the top of the stack now, goes down because this space is now made available, right? That's important to see because once you go out of block, that's why if I say over here, if I say on the top over here before, if I say C out I, right, over here before this block, of course, that's ludicrous because it never encountered I. But if I go after the block, if I say C out I, it's just as ludicrous because I ceases to exist. It does not mean that the variable, the space in RAM that used to be I goes away. That's still there. It doesn't mean that the 10 that was here goes away. That's still there, but it's inaccessible because the semantics of the language says that once you go out of the block, you can't use it. It's not there anymore as far as you are concerned. Okay, but you got that? Right. So those are called automatic variables. They're automatic because they pop automatically into existence when you enter the block in which they've defined, and they automatically come out of existence when you exit that block, when the flow of control exits the block, right? And why, right? And that's handled in this particular area as a stack, right? And that's called the runtime stack to handle the automatic variables. Is that understood? Is that clear? So therefore, when we said something like, I have an integer variable I, right? Here's I is equal to 10, right? That set this thing up here, someplace 10, right? This is a thing called I, and it lived at, let's say, 100A. And then I also said int star IP is equal to the address of I. So that set up IP over here at some address 500A, right? And it got the address of I. So this has a 10 in it, right? I has a 10 in it. And IP, right? I say that IP gets the address of I. So what is IP? IP gets 100A, right? Where do all these things live? Where does I live? I lives in the runtime stack. That's a regular variable, an automatic variable. Where does IP live? IP lives in the runtime stack. And if they're defined within some particular, of course, they're defined within some scope, right? As soon as that scope is exited, both IP and I disappear, right? What about when I say something like I have a variable, I have an array int a, 3, and then I initialize it, right? Where does a live, right? The array a, where does that live? Does that also live on the runtime stack? Absolutely, right? Absolutely, it lives on the runtime stack, and as soon as you exit the block in which it's defined, it goes away. Okay, any questions about that? So here you have the data, right? Or here you have, the code. And then so far we've seen where these kinds of variables, statics, globals, and constants are stored. Then we've seen the runtime stack, right? That's where the automatic variables. And what is all this stuff? This stuff is for handling dynamic memory. Okay, let's check that out. Actually, let's not check it out. Let's check it out when we need it. Give me a second. All right, are there any questions right now about any of this stuff? No questions. All right. So then let's go back and actually look at the look at the program that we want to use as a jumping off point to see how this stuff actually works. So this we did yesterday, right? We have the header file, and the header file is what gets pound included. And then you have, so I can include the header file many places. I only write it one time, and we saw the header guards, and here is the implementation. So let's see what it is that we want to accomplish. We want these strings, and I want to be able to do certain kinds of things with my strings. One other thing I wanted to show you. All right, before we do, was what we did yesterday with the two-dimensional array and the pointers, did that make sense to everybody? Before we go to this code over here. Any questions about that two-dimensional array stuff? Guys, I can't see your head bobbing or anything, so I need you to talk to me. Any questions? Was it completely clear?
Yeah.
All right.
Yes.
All right, so let me actually run a program to just show you. Let's just talk about that just a drop more. Just drop more. So we saw that if I have that array B, just to go back, then we'll come to the program. Have that array B. And how did that work? I have integer array B, and it was what, 3 rows and 2 columns, right? And it had what it had, right? So we saw, right, 3 rows, 2 columns, and we saw how to get to the arbitrary, B sub. We didn't see the arbitrary one. So let's say what I want to now do is just to finish that thing, and then we'll run some code, and then we'll go back to the actual program. That's the thing to do for the next day or so, and that is the following, right? I know that I can say I want to be able to say B sub I J, right? B sub I J, and that what is I? I is the row, right? And J is the column. And I want to be able to say B sub ij is equal to, let's say, 10, right? I want to write B sub ij without brackets. I just want to rewrite this thing using the dereference operator. Does that make sense? I want to write something like B plus blah 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 dereference instead of brackets, right? Everybody take just 2 minutes. Let's try to do this in 2 minutes. I want to rewrite B sub ij like we did yesterday, but what we did yesterday was B sub 1, generalize that, or whatever we did to get to someplace, right? Generalize that. So I got to the arbitrary place in the array. Okay, let's try that. All right. Let's see how we might do this. All right, so help me along here, right? So I have B. So what I want to do is when I say B sub ij, I is the row and j is the column, right? So let's say I'm talking about, so this is 0, 1, 2, and this is 0, 1. So if I want to go here, let's say, this is going to be position what? Where is this going to be? It's going to be row 2, column 1, right? In order to get here, I have to go down to 2 columns, right? I have to go down 2 columns. So what is B? B is a pointer to the first row. We saw that yesterday. B plus 1 is a pointer to the second row, right? B plus 2 is a pointer to the third row, right? Right. So when I say B sub 2, 1, I got to go down. So I say B, that, and I say plus 2. That takes me over. This gives me a pointer to this particular row, and I want to get in there. Does that make sense to everybody? So if instead of going to row 2, I want to go to row I, right? I is the row. I would say B plus I. Does that make sense? Instead of B plus 2, it's B plus I, right? So now I'm in row I. Let me just shut that down. So now I'm on row I, but what is B plus I? B plus I is a pointer to row I. So then when I dereference this, that gives me a name for this particular array, right? B star B plus I is the name of that array. Now, if I want to get to the position 1, I would basically say, sub 1. But the problem says if I wanted to get to row to the jth column, I would say, go not to 1, but go to j, right? If I were allowed to use brackets, but I'm not allowed to use brackets, right? So if I have a one-dimensional array, which is the one-dimensional array, how like that array A that we had, right? So if I want to get to this position 0, 1, 2, so this is A. This over here is A plus 1, the pointer, right? This over here is A plus 2, right, over there. But what is A? A is the name of the array. So likewise here, star B plus I is the name of the ith array. And I want to get to the jth element of that, right? I want to have a pointer to the jth element. I use the name of the array plus j. This is the element 0, element 1, element 2, right? So if j is 2, it's A plus 2. So this is the name of this array in red. To get to the jth element, to point to the jth element, it's the name of the array plus j. But I don't want the name. I can't. In other words, I don't want a pointer because I can't assign this. This is a value, right? I have to take this is a pointer value, not a pointer variable. I want the name of that, right? I want to get a reference to this particular place, so I have to dereference it, and that's going to be the name of there. Right now, I can use the name in two ways. I can assign to it, right? I can say this thing is equal to 10, or I can print it and so on. So the answer to the question, how I write this thing in most general terms, is this. Okay. Those of you that did it, did you do it like this? Is this what you got?
Yes.
Okay.
Yes, Professor.
Those of you that couldn't get it, do you understand it? Maybe not understand it. Everybody's any questions about it? No questions about it. Okay. So let me just show you something else. Let me come here. I want to share my screen again. I'm sorry. Let me share my screen. Not this one, and we say share. You can all see the program here, right? So I have a main program. I'm defining this array. Here's the array I, the array B. It's the same array we've been playing with, sort of, right? So there's three rows, 2 columns, and we're initializing this thing to first row, second row, third row. Now, if you look at this, slightly different than what I had, we've been working with until now, in the sense that beforehand we said I just simply had one set of brackets, and I said 1, 2, 3, 1, 2, 3, 4, and so on. Here I'm explicitly breaking off. This is the first row, and this is the second row, and that's the third row. The way that we wrote it earlier, that works in most compilers. Some compilers are finicky, and you have to write it like this explicitly say what goes in each row. But in most cases, the compiler can figure it out by itself. All right, so what is this program doing? So this is the array that we looked at, and this is going to print out B sub 0. What is B sub 0? That's what is it going to do? When I say print, is it going to print out the first row? This says print out B sub 0, B sub 1, B sub 2. What do you think is going to be printed?
The addresses of each array.
Why the addresses? Good, right? Why the addresses? Well, first of all, because it can't print the whole array at a time. This is not Python, right? So it's going to print something. So it has to. Remember, C++ is very generous. It tries generously and tries to interpret what is it that I mean. So it says this guy probably knows C++ a little bit. He knows it can't print the whole array. I'm just going to print out what? I'm going to print out the address. That's what he means. So we can print B plus 0, right? B plus 1 and B plus 2. And then what's going to happen over here is that it's actually going to use what we just saw, right? And it's going to print I goes from 0 to 3. These are the rows, and the columns go from 0 to 1, right? 0, this is going to be 0, 1, 2, right? Less than 3. It's going to be 0 and 1. This is going to print out the array, but it's not printing out by saying, B sub ij. It's going to do what we just saw now, right? In other words, it's going to use this form of it with the stars and with doing the arithmetic. And let's see what happens when we run this thing. See what happens when we run it. I'm not doing anything. Okay, I want to run. There it goes. Right. So first of all, let's see what the addresses are. So when I say print out B0, it's printing out 0xCFFE00. Now, what in the world is that? Can you all see this? What is that? So this is, what does 0x mean? These are addresses, right? So what does 0x mean? If you know, speak, right? What does 0x mean?
I don't think we see it.
Oh, you're not seeing it.
Yeah.
Thank you, thank you, thank you, thank you. Okay, hold on. Stop the share. The screen. Thank you. Don't let me, you got it. Okay. Now you can see it, right? Can
Yeah.
you see what's behind it? The actual function, you don't see the program anymore.
No, we
right?
don't see the program. We just see the
Okay,
command
but
window.
it says that, okay. So what is this? What this is 0x6FFE00. That is an address. But what does the 0x stand for? What's 0x stand for?
Hex.
This is hexadecimal, right? This says that the following thing is to be interpreted as hexadecimal. What's hexadecimal? Everything is this is 16 to the 0, 16 to the 1. So the start of where this particular two-dimensional array in memory is at this position here. Now, it says, so I said, give me B0, and then I said, print out B1, the address of the second row. Now notice, where is the second row? And this starts at 0, 0. This starts at 0, 8. What does that mean? These addresses are addresses of what? Of bytes. These are byte addresses, right? All the addresses are byte addresses. So why is it 0, 8? It's 8 away, right? Why is it 8 away? Because every row has 2 integers, right? How big is an integer? 4 bytes. So every row is 4 bytes. So this starts at 0, 0. 8 bytes away is the beginning of the next row, which is at 0, 8. Right? Now, 8 bytes away, right, from this, because I say print out B2, which is the third row. So that says it's at E, a 1, 0. What do you mean 1, 0? What does 1, 0 mean here?
This one. Oh, that one represents like 16.
That's 16, right? In other words, it doesn't mean add 2 to the previous one. All this arithmetic is done in base 16. So 8 and 8 is 16. 16 is 1, 0. So this moves away, another 8 bytes. See that? And then it prints out 1, 2, 3, 4, 5, 6. This is what's in the first row, second row, third row, right? And I did that using only pointers and the pointer arithmetic. And the guide here on the bottom is I asked it to print out well, let me show you. Just, you see this thing says 1, 8, right?
Yep.
On top here it says 1, 0. This thing says 1, 8. Let me go back and share again. This should actually work somehow. Can you at this point, you see the code, or you see still the printout?
See the printout.
You see the code? Oh,
Um,
okay. Oh, you don't see the code. Okay. So then I have to stop the sharing. Let me then show you code. All right. So then I said, print out the address of B+1. And that's the thing. What did it say this? What did it say? What did it say?
18.
18.
E18.
E18. And before it said E what? E10, right? So we went from 10 to 18. Why is that? What does 18 represent? When I say address of B+1, and I got 18.
It represents the address of the first element in the second row.
I don't know. We saw, no, that couldn't, right? Because we saw the one in the second row. No, that wasn't that, right? What was the address of the one? Write this down, actually. Let me get back here and stop the share again. Let me show you that again.
Is it,
One second. Write down these numbers, right? The first number was 0008, which is not 18, and then 10. So just write 0008, 10, and then 18. These E's, don't worry about those, right? So just write those numbers down. Okay, so we're going from 10, right? That was the beginning of the third row, beginning of the second row, beginning of the first row. And then when we say the address of B plus 1, we get 18. Huh? Okay, you see, let's write that down and let's go back to the program. Right, it said take the address of B and add 1, and it said 18. What does that mean?
Is it 18 the hexadecimal address of where B the array end?
Why would that be? Who's speaking? Again?
Oh wait,
Wait, okay. Why would that be? You hear what he's saying, everybody? He's saying that that's the address, not where it ends, but perhaps one after where it ends.
yes.
Yeah, why would that be? Does that explain that? Why would you think that that's the case?
And hexadecimal 18 is 24, and since this is a integer and 3 by 2 double array, it requires 24 bit. So after 24, it will be after 24 bit from 00 will be 18 and hexadecimal.
Very good, excellent. Let me just make sure that everybody got that. So the question is like this: when you say the address of B, remember we did yesterday, we talked about the size of, right? We had the array A, and the array A was 3 integers, right? So when we said size of A, it came out with a 12, right? Size, why? Didn't we say that A is the pointer to the beginning of the array? And the answer was context. It depends, like they say, when you're buying real estate, what's the 3 most important things to buy real estate? Anybody know? Location, right? So here is context, whatever. So if it just sees B by itself, it knows, if you look over here in the program, right, it knows what B is. You're telling me B is an array, 3 by 2 array. So you ask me the address of B, it means the address of this whole thing, the whole golump, right? So when I add 1 to it, it's going to take me after this whole object. Now, since as we saw, this object starts, the last 2 digits of that address was 00. So it was 24 bytes starting at 00. So the address, if 18, as Wade said, is 24, that makes sense, because it's going to move over how many? It's going to move over from where it started plus 1. So plus 1 is a position 24 from where the array begins, right? Because these 24 start at 0, so that gives me 24. Very good. Everybody understand that? Okay, let us take a break. Let's take a 10-minute break. Now, what time is it? Come back at around, I don't know, it's 12, so come back at 22. Okay? And just remind me to turn the recording back on. Recording. Okay, so say the question again. Who's asking? Babita, who's asking the question? Oh, yeah. All right, so what's the question? Could we explain what the B plus 1? All right, let me share the screen. All right. So who answered before? It was Wade Lee. Who was it answer the question before?
It was me.
Okay, so you want to explain it again? And then I'll do it one more time. So what was your explanation here?
Okay, so the address of B is stored as 00 and hexadecimal,
Right.
and the first and since is a integer of size 3 by 2, it requires 6 times 4, since each integer require 4 bit,
Bytes.
and there's byte, and there is 6 element, and there's 2D array, so it requires 24 byte, and hexadecimal 24 is written as 18, so the first empty space after the 2D array would be 18.
Okay. All right. So let me just go over that. That's it. Exactly. It's a good explanation. Let me go get some clear space. I'm gonna stop the sharing. I'm gonna go back to the page that I can actually write on. Share again. So it was the address of B plus one that we were looking at, right? So it said, take the address. Get a different pen. So take the address of B. Is that what it said? The address of B. Like that, plus one. Is that what it said? So how big is B? We know that B started, when we looked at the output, it said that the starting address of B sub zero, right? The first row, remember? So the address there was 0, 0. That was, and it had stuff over here, some hexadecimal number, 0, 0. And then the address of the first row was an 8, right? 0, 8. Why? Because each one of these things is 8 bytes, because this is an integer and an integer. So to go to since it starts at 0, 0, when I move to 8, so 0, 0 plus 8 would be 7, right? 0, plus 8 takes me, there's 8 bytes, but it takes me from 0 to 7. And the very next one, the next row begins at 8, right? That's why the address of this was 0, 8. And the next one was, what was it? 1 what? 1, 0, right? That's where this thing starts. Why is that 1, 0? Because that's 8 away, right? Which is really, if I add 8 and another 8, and I do it in hexadecimal, so this is going to be 16, but 16 in hexadecimal is 1, 0, right? Because every place here, the first place is 16 to the 0, and then that's 16 to the 1, and then 16 squared, and so on. Okay, Babita, so far so good?
Yes.
Okay, so now the question is, what happens when I say address of B plus 1? So in this context, the compiler says, well, what in the world is B? So it looks at my code and it said, well, you declared B to be a two-dimensional array of how many integers? 6 integers, right? Every row has 2 integers, 3 rows. So 2 times 3 is 6. 6 integers has how many bytes? Has 24 bytes, right? So if I start counting at 0, 0, so the byte addresses goes from 0, 0 all the way up to what? To 2, 3, right? This makes 24 bytes. So this says go one past. When I go one past, that's going to be 24. And that's where that came from. Does that make sense to you? Now, the point is, the real question is, when it says plus 1, what's the granularity of this arithmetic? In other words, it's moving by how many each time? In other words, right, we saw that if I'm talking about an integer, and let's say let's say IP is a pointer to an integer, IP plus 1, if this is a pointer into an array, moves me to the next position in the array, IP plus 2, and it moves 4 bytes each time. When I say this plus 1, how many bytes did I move each time? I'm moving how many bytes? I'm moving 24 bytes, right? Because it says over here plus 1. So the object that the thing that I'm pointing to, that's pointing to something of size 24. So this says move over 24 bytes, and you're going to get to the beginning of the other one. So this thing, that's the granularity of this operation. If I say plus 2, it's going to move me another 24. Okay, that's what's going on over there. All right, is it clearer?
Yes, thank you.
Very good. All right, let's go back to the code now. And here. Okay. All right, let's actually see what's going on. Right. So we want to make a string class. Right. Here's a string class. So let's see what kind of things I want. Let me make some room. What do I want to do with this? Make some room over here. So if I let's see what's it letting me do? What's it letting me do? It says I'm writing some code that I can have a default constructor and a something, a copy constructor, and initialization, and I can concatenate strings, I can compare strings with Boolean, I can assign one string to the other, and so on. So we're going to see the definitions of these things. So now it turns out, I think somebody actually mentioned yesterday, that in C++, you get a couple of things for free. Whenever you define a class, you get things for free. So let me, before we come back over here, let's go back to our rational number. I'm going back to the rational number class. That should be right after here. So here is this rat class that we sort of looked at a little bit. Make some room here too. Right. I don't have the actual use thing of it, but let's see, how am I going to use my rational number class? I'm going to be able to say something like this. Look, I have a rational number, right? I have a rational number. Here's a rat class, and I'm going to say that X is a rational number 1/2. And then Y is a rational number, let's say 2/3, and then I have a Z, right? And I want to be able to say in my program, I want to say Z is equal to X plus Y, and I want to do the appropriate thing. I wanted to say add 1/2, and I wanted to add 2/3. I wanted this thing should create a rational number, right? Because I'm using this has been an overloaded plus for rational numbers, and it should give me a rational number with the appropriate values. How much is 1/2 plus 2/3? So how do I do this? I get the numerator, I get 2 plus 2. 2 times 2 is 4. 1 times 3 is 7, right? Right, so 1 times 3 is 3. 3 and 4 is 7. So the numerator is going to be a 7, and the denominator is going to be a 6. Is that right? So this should create, when this thing comes back, assuming that it's right, when it comes back, I'm going to get an object that looks like this. The numerator is going to be 7. The denominator is going to be 6. That's what comes back from this operation. And then, but that's an anonymous value, right? I don't know the name of this, right? But whatever it is kept in some temporary storage. And then this is going to be my Z. And in my main program, I can say Z is equal to that. And so what's going to happen is Z is also a rational number, right? So this is going to say 7/6. Everybody got that? So now let's take a look at, give me a second. Let us take a look at the member functions of this class, right? So here's what it looks like. It has numerator and denominator. What are the member functions? We have these constructors, default constructor, I have a 2-parameter constructor that I'm using over here. I have a conversion constructor, which we'll see later on. I have getters and setters. I have plus, and I guess that's the end of it, right? And if I just do that, the compiler will do this for me. It will let me say, I will not get an error message when I say Z is equal to X plus Y. So that's surprising, right? Why is it surprising? Because just like plus is an operator, assignment is also an operator. So before I teach the compiler what I mean plus for my rational numbers, why don't I have to teach it what assignment is? Everybody got that? And the answer is because in C++, assignment, if you don't define for your class assignment, it gives you one automatically, right? So what you get for free is assignment is one of the things. Okay, sorry for that. Assignment is one of the things you get for free. So therefore, you don't have to define it. Again, I spoke about it a little bit yesterday, but as I pointed out yesterday, is that many times what you get for free is worth it. But the rational number class is not one of those things. What you get for free over here is exactly the right thing, right? And what is it going to do? What's it going to do in this assignment? Well, it's assigning a rational number to a rational number. So it's basically going to copy the bit pattern of the numerator to the bit pattern of the numerator of Z, and the bit pattern of the denominator of this, anonymous object here is going to copy it over there, get the 6, and that is exactly what you want, right? So, in this case, it works fine. Now, what really happens is a little bit more complicated, and we'll see that later on. But for this case, it works. It was okay. Now, there are three other things that you used to get for free, and you still get it for free, and that was a you got the assignment, you got a default constructor. You got a what? Everybody know what else you got over here? You got an assignment, default constructor. Anybody? What's the other things you got for free?
Do you get a default destructor?
You get a destructor. That's not something out of Harry Potter, right? Destructors. What else you get? There's one more things.
Copy, copy.
What?
Copy constructor.
Copy constructor, right. So we're going to go through all of these things. So, and what does that mean? You get them for free. That if you don't put them, you're going to get, it will automatically give them to you. However, if you define any of these things, then you got to define all of them, because it assumes that that you know what you're talking about. You assume that your class can't use the defaults for some other reason, so then it forces you to write the other ones too. Okay, so, but if you don't, like for example, in this case over here, that's not completely true. If you write assignments, essentially, it's gonna ask you. We'll get to the details in a little while, but it assumes if you do anything that's substantial, right? If you write assignment, it's going to make you do the copy construction because it says, you know, it says there's something special about this class. This used to be the case up to 11. In 11, you get two more things for free. And we know what those are. What do you get for free? You get a two more constructor. Where you get a something called a move constructor. A move constructor, and you get an assignment. Now this move, you get move assignment and move. So you get one of these. You get a move of that, and actually a move copy. Right? So it's a move copy, and a move assignment. What does that mean? Move. And why do I need them? We will see. So this is what you get. So you get move. You get a copy constructor and an assignment that do moves instead of whatever the other guy was, and so you get these six in everything over any compiler that's conforming to the standard PSC plus us 11 and on. And if you have an older compiler, all you get is this. And we're going to go back to this. We'll meet these again and again as we go through the code. So let's get back over here. So what do I want to do here is I want to be able to use strings. I want to be able to use strings. So for example, I want to be able to declare a string. So how do I declare a string? So what's the name of this class? I think it's called capital string. So I would say something like, I have a string, right? I have a string, and my string's name is S. I want to be able to say that. So in order for that to be said, what constructor is going to be invoked, right? So what's going to happen once I say that? First of all, I'm going to get an object of string type, right? What does an object of string type look like? It's going to have a pointer and a length, right? It has, I'm over here now, right? So I have a pointer and a length. I'm going to reverse them because it's going to be easy to explain as I go along. So in other words, it's going to have two things. It's going to have a length over here, which is going to be an integer, and then it's going to have a pointer called str. There's going to be a pointer to something, right? So this is an integer, and this is going to be a pointer to what? Well, we'll say, oh, here it says, right? It's going to be a char star, right? So this is going to be a char star, which means a pointer to an array of characters. That's what a string object is. Now, what does that mean? It means that remember we talked yesterday that C++ is strongly typed, so I can only put integers in here, right, to this guy, and I can only put pointers in here. But even though all pointers are the same size, right, namely all pointers of size 8 bytes, which is what we're going to assume, the compiler will enforce the type. If I try to put an 8-byte pointer to an integer instead of an 8-byte pointer to a character string, it's going to complain, well, let me do this because it's strongly typed. Okay. So now, but I do have a default constructor. And why would I even need a default constructor over here? What do you think I need a default constructor? What's the point of it? Anybody? There's a sort of unintended pun, because did we have a default constructor in the case of the rational numbers? Well, we did, because what's a rational number? Rational number is numerator over denominator. And I want to make sure that if I say, give me a rational number X, I want to make sure that what's not the case. I never want to have the denominator to be 0, because if somebody, if by accident if I leave this thing, if I don't have a default constructor, and I just say, okay, give me an X, and I didn't define what to do, if by some random chance I get memory that has a 0 there, and then I use this, I'm going to be dividing by 0, and my program will blow up. So I want to have a default constructor that's going to make sure that there's no 0 here. If you look at that code, it put a 1 over here, put a 0 here, but a 1 over here to make sure that it's not going to divide by 0, right? So in cases when you're dealing with numbers and you might divide by that, you want to make sure that that you do the initialization. Likewise, when I have a string, I want to make sure that I don't have some random bit pattern over here. I want to initialize all my strings. Because if I have some pointer, if I say I have an int star, let's say IP, and I don't initialize it, whatever random junk is in there, like a whole bunch of stuff, if then I say take IP and then dereference it, and it's pointing someplace in memory, and I say, put a 19 there, and it just breaks up some very important system table, I'm messed up. My whole program is going to die, and I have no idea why. So this is a really real problem. When you're dealing with pointers. Pointers are very, very, they're not complicated in the sense that you pay some attention, you figure out how to work with them, but they're very dangerous. You have to remember stuff. You have to remember a lot of stuff to check when you're dealing with pointers, right? And a whole industry has grown up of tools that will check your programs to make sure that you don't make the obvious errors, with pointers, like forgetting to initialize them, right? Because of that, C++ later on, in 11 and so on after that, and we're going to look at that, they created something called their objects that behave like pointers, and we'll actually see how those things are constructed. We'll actually build them, and then we'll see how C++ actually built its own. Right? So that's the idea. So you want to initialize your string, because since you have a pointer over here, you want to make sure the pointer is not some random stuff. So let's take a look at the default constructor, which is right over here, right? So the default constructor says, when you say string X, so I'm going to do the following. I'm going to allocate this space over here. This is going to be called what? This is going to be called length. Got to go the length of my string, and this is string, and that's a pointer. So what should be the length of the string that's undefined? So the length is going to be 0 because it's not a real string. So I say len is equal to 0. And what about the pointer? That's interesting. What about the pointer? Now, before we go on, I want to make sure, and I'm sure you know this, I just want to make sure we all know the same thing in the same way. When we look at what is it made out of, right? We said, what is the, when I create one of these things out of, I said, give me a string. It has a string and a length, right? But however, this thing over here is private, which means you should not have access to the internals of the class, right? You shouldn't be able to say like, x dot Bob. You can, I'm sorry, x dot name, like we saw with structs, right? You said x dot, you can't use the dot over here because you're not supposed to know about the name, right? Because it's all private. And even though we don't say private over here, we saw that when you declare something to your class, then by default, everything is private, right? So str is private and length is private. And yet, if you look at the member functions, so it's using those things directly. It's using length and it's using str. So how does that work? Okay, so it's, it's not a joke question, but you just want to make sure you know very clearly what's happening. Why can't I say length? Why can I access the word length directly, even though it's private? And the answer is, somebody speak up, please. The answer is what? Come on, come on, come on. This is. Okay, somebody. Sadman, what do you say? Good morning. Right, what do you say? Why can I directly use length, even though it's private? Durga, what do you say? Why can I do that? Sadman is thinking, what do you got? Why can I say len? Because
it's not accessible, so
it is, right? It's not because it's private. So how come I can use it? How come in the member function I can use it? This is actually fundamental stuff. Jared, why can I say length equals 0, even though length is a variable that is private? So let me just ask something very important here. So even though your cameras are on, is everybody paying attention here? Because it's silly to sit there for 2.5 hours and just sort of daydream, right? Why can I say length, even though length has been declared to be private? So do you remember that? Remember, I had a diagram yesterday. Remember the diagram?
Professor, can I try?
Yeah, who's talking?
My name's Anand.
Okay.
Even though it's private, it's still in the scope
It's still in what scope?
of the class. Like even if the variable is private, it will still be like I can still use it when I'm using it within the class.
So, right, that's true. Explain in a little bit more detail. That's absolutely right. So explain it a little bit more detail.
I guess like I mean when you use the modifier private or protected or public, like when you're using private, you're just making it inaccessible to classes and methods that are out that reside outside of that particular class. But if
Exactly
you
right. That's it, exactly right. Remember, we had it. Very good. Thank you. I'm not stopping you. I mean, because you're clear. I want to make sure everybody else understands it. Remember this diagram, and here is what's the president's name? Whatever, Biden, right? Biden is sitting over here, right? And here am I, right? I can't access Biden, right? But this because he is private, right? But here is his cabinet, right? Here's the guy, the Secretary of Education. Here's the Secretary of Defense. Can these guys access Biden? Do these guys have access? The guys on the inside, they do. Does that make sense, right? So I user of the class, as we just said, right? That's what he just said, which is correct, right? The guys outside have no access to the internals, but the member functions themselves, of course, they have complete access. They can call on other member functions directly, and they can also use all the data variables. Is that clear to everybody? So that's why, I mean, that's sort of an obvious thing. I didn't, so that's why I can say length is equal to 0, because this is a member function, right? This belongs to the class, right? Now, just to make sure that's clear, what does this mean? What is the 2 colons? Right? It's called a scope a resolution operator, right? It tells you what the scope is, right? So it says that this function here, this function string, belongs to the scope. It's resolving the scope. The scope is the string class, right? Likewise, all of these things. Why are we writing this? Because this is a separate file. So when this file gets compiled, it says, well, what is this? Where's this from? Right? This is using variables. It's using length and str. Where do I find that stuff? So it says all this comes from the string class. These are, so the scope of this, we want to know where the variables come from. That's string. Okay. So that's why this thing works, right? Because it's a member function, and member functions have access to the internals of the class. Okay. So we know one thing. Well, one thing we see what happens is that the length is going to be 0. But what about the pointer? What about the pointer? So the pointer says the following thing. It says new. Now, if you've never seen this, this is important. It says new char. Gotta spell it correctly. New char bracket 1. Let's see what that means. So what new means, what does new mean in Java? Somebody, anybody, what does new mean in Java? When you have a class object, you say new, right? So what happens when you say new?
You create an instance of that object.
You create an instance object. Now, where is that instance coming from? So that's what you have to look at and see what new means over here. So let's get back to the previous diagrams, unless I erased them, which unfortunately I probably did. Oh boy. Keep it simple. All right, so clear up this stuff. Remember, we said, here's what's going on, right? We have, let me write in something we can find it, right? So remember, we have, this is your runtime. This is what's going on when you, so here we had the code was over here. We had the what? We had the static, etc. over here. And then we had here, we had the runtime stack, right? And here we had the stuff, and we didn't go through it. This is the dynamic memory. You should actually, this is a very important diagram to make sure you write down, right? Don't sit there and dream, write this thing down. So the dynamic memory, as opposed to the automatic memory, the automatic memory is called automatic because it is automatically allocated to you. You don't have to ask for it. When it gets to the declaration, so when control flows through something like int I, boom, I is automatically allocated for you. And when I goes out of scope, that variable is automatically taken back. You don't have to worry about that, right? You don't have to ask for it. It just says, you just declare, I'm going to use an I, and it'll take care of allocating it automatically. Here, though, sometimes in the program, you have to explicitly ask for memory. And it'll give it to you dynamically as the program runs, but you need to ask for it. But if you do that, and you're going to get it from this area over here, when you do that, you have to explicitly return it. Okay, so let's see how that works. So this area here is where the dynamic memory is, right? Let me show you this thing over here. Here's the dynamic memory, and it's broken up. Traditionally, it's broken up to sort of two pieces. Right, one piece is usually called the heap, and the other one is called the free store. Okay, so what's the difference? They both offer dynamic memory. Generally, the word heap is used to, remember, C++ comes from C, right? So the word heap, the part of this dynamic memory area, which you can ask for space from dynamically, part of it handles the dynamic memory in the way that C does and did, and some of it handles it in a different way, which is the way C++ does. So what is that? So we're going to look at the C++ stuff, and then we'll go back and look at the C++. If I want memory, so usually this is the C and this is the C++, even though I'm going to always use the word, I'm going to say heap all the time, but we're talking in the context of C++, so it's going to go from the appropriate place. It's going to go from the free store. And we'll talk about the differences later on. So how do I ask for memory from the heap, basically from the free store? What do I say? So I say new. When I say new, this is a construction in the language, and what it does is new says I'm knocking on the door of the dynamic memory manager, and I say I want some memory. And then if I do this, if I say new int, for example, so the memory manager rummages around in his area, and how the memory manager works is really fascinating. It's amazing how it works. And we will go very deeply into that. We'll actually look at the code for the memory manager, first in a general way, and then we're going to look specifically how you can implement your own memory manager for your classes. It's really amazing stuff how this works. But in general, if I say new int, the memory manager, the one that lives here, is going to look around and find space for an integer. And so let's say here it is, here's the place that is found to the integer. And what this is going to return, this returns a pointer, returns an address, a pointer for what? It returns a pointer to the place that it's found for you, right? So it looked around, is there 4 bytes that I can put an integer in there? Yeah, and it's going to be the place. So this returns a pointer. So if this is going to return something, you have to have a place to keep it, right? So I would say something like int star. Let me fix something over here. Let me get this one, probably bigger. I'm going to say int star is equal to int star. I'm going to say int star is let's say IP is equal to new int. So look what happens over here. What does new int do? New int rummages around over here in the heap, finds a place, returns an address, and it's going to be stored in IP. Now, what you have now, this you never saw this before, is that you have a sort of schizophrenic object. When I say int star IP was equal to new int, so where is this integer that's being allocated to me, this new integer? Where does that live? That new integer lives here on the heap. Here it is. Where does IP live? Well, this is a regular declaration. IP is an automatic variable, right? I have a scope over here, right? This is the beginning of the scope, here's the close of the scope. This is a declaration, and this is a declaration of an automatic variable. So IP comes into existence at the beginning of the scope, right? When I hit this line, it gets this initialization. So the situation looks like this. IP is IP, that lives on the runtime stack. The actual integer lives in the heap, so the picture looks like this, right? On the runtime stack, I have the variable IP, and then it's pointing to C. Everybody got that? Is that clear to everybody? This is absolutely fundamental of what we're going to look at. So is there any question at all about what this is? No question at all. Does everybody see how this, this construction over here creates a situation where part of this thing, right, the name of the new integer, that lives on the runtime stack, and this now lives in the actual place that things are going to be stored, that lives on the heap. Okay, very good. Now, how do I want to put 100 right now? It's uninitialized, right? I mean, my integer is, what's in there. How do I get, let's say, in this place, I want to put a 10. How do I get a 10 over here? How do I have access to this place? So somebody talk to me. How do I-
Reference IP,
Right, dereference. So what do I do? What do I say?
star IP.
Right, very good. I say, let me go back to the other pen. Right, very good. So I say star IP gets a 10. Does everybody see this? This is absolutely, somebody actually asked me this question at the very end of the class yesterday. How do you actually, when you talk about the address and so on, does it make a difference where the addresses come from? And the answer is no, you treat them the same way. Now this has to be a simple variable, right? So star IP means take IP, which is a pointer, dereference it. So where does it point to? It points to here. Dereference it gives me a name for this location, even though this location does not live on the runtime stack, right? And it's going to put a 10 in there. Okay, is this absolutely clear to everybody? Yes, good, okay.
Yes.
Okay, now, does anybody see a problem with this? Not this specific example, but a problem with having a schizophrenic object where part of the object lives in the runtime stack and part of the object lives on the heap.
The variable on the runtime stack on the automatic variable leaves its scope, it'll be lost. So, the reference to it will be lost on the stack. So you can't access the object on the heap anymore.
Excellent. You have a name for that phenomenon? Very good. Please, everyone listen, because you got a bunch of smart people here. You're all smart, but what is the, give me a name.
Memory
for the
leak?
phenomenon. What,
Memory leak, I think.
Excellent, excellent, excellent. Very, very good. All right. So what he pointed out is that this leads to a potential memory leak. Right? Now, what does it mean, a memory leak? It means that you have that, it doesn't mean that the chips sort of fly off the motherboard, right? What it means is there's memory in this, you've been allocated this whole thing, right? This now belongs to you. This whole area, belongs to you. And you want to be able to make maximal use of it, right? You don't want stuff that's in here. You don't want locations that you used to store stuff. You don't want it to become unavailable to you, right? But in this case, it could be, right? Because since the IP, right, this pointer lives on the runtime stack, let me put it back over there, right? IP lives on the runtime stack. If this is in, if this is in some scope, right? So as soon as the scope exits, IP not there anymore. But what about this? What about the place that the 10 is stored? What about that place? Right? Well, unfortunately, the only way you had access to that place is via the pointer in IP. But once it goes away, right? Once it goes off the runtime stack, remember we say it's still there, right? But when the runtime stack, which is a stack with a pointer to the top of the stack, gets decremented, that IP is effectively lost, even though it has the appropriate address. You can't get at it anymore. You can't do that, right? So therefore, you have a memory leak, which means that memory that was until now available to your program is inaccessible. And this is not like in Java. Does this thing happen in Java? It doesn't, right? Because first of all, you don't have pointers to play with, right? But you don't have memory leak because Java does automatic what?
Garbage
Yeah,
collection.
garbage collection, right? It does automatic garbage collection. It keeps track of, which locations are in use, and then when it figures out they aren't in use, it'll clean them up and make them available back into the pool. Now, does C++ have that? Not what you learned in 111, and not what was the case in C++ up to C++ 11. But now from now on, there's pointers that do automatic cleanup, and we'll see how that works when we get to them, right? But anyway, so what do you do about this? So the thing is, how did we get this memory in the first place? There was a new verb that we introduced, and that verb was new. New gives you the location, and if you want to return it, then you have to say delete, DELETE, right? Delete. Now, delete what? What would you delete? You would say delete IP, right? You'd say delete IP, but where would you say delete IP before the end of the scope, right? Does that make sense to everybody? You have a scope opened up here, and then you declared IP, and at the end of the scope, right, here's the end of the scope, IP disappears. So you better, before you end the scope, you better say someplace, delete IP, right? Delete IP. Why? Because after you exit the scope, IP is not known anymore, right? That name disappeared, so this is impossible. So now we have two new verbs in the language. We have the verb new that gives you a memory, whatever you asked for, and then delete, which is going to return the memory to the memory manager so we can reintegrate it into the pool. Does that make sense? Yeah, good. All right. Now, what we did over here is we allocated a particular integer, but what about if I want to allocate an array? Right? I want to allocate an array. I want an array of integers. So how do I do that? So I want to allocate an array. I would say IP is equal to new int, and I put a bracket, and I have to indicate how big I want that array. Let's say 100, right? And that's going to give me a pointer to 100 integers located one after the other, right? Consecutively in the heap, right? And new will return the address of the beginning of that, and it'll keep track of how internally in the background, it'll keep track of how big the array is, how many bytes it has, and so on. And since it's being allocated dynamically, just like before, if this happens in a scope, as soon as the scope is exited, what's going to happen to IP? IP is just a regular pointer variable. It's an automatic variable that's going to disappear. What's going to happen to these 100 forlorn integers over there? They become orphans. We've lost 100 times 4 bytes. Does that make sense to everybody? So therefore, we also have to have a way of deleting. So we would say there's a way of deleting an array of memory locations, and that is delete bracket IP. Even though you would imagine that it makes more sense to say delete IP bracket somehow, that's not the way to do it. Delete bracket is the name of the operation, right? So you use delete by itself if it's a single variable, if it's a single object that you're pointing to, and you say delete bracket and the name of the pointer if it's an array. Okay. Now it does even more than that. We'll talk about that later on. Because it's calling destructors if you have destructors. Likewise, when you say new doesn't only allocate space, but also calls the constructor. We'll get to that as we go through the code. Okay, does this much make sense, everybody? Is it clear to everybody? Any questions? No questions. Okay, let's get back to the code. So let's see what happens when I say string X, right? So the first thing is that I get space for my string, and the length was set equal to 0. What about the pointer? So the pointer says the following. The pointer says, give me, I'm talking to the memory manager. New means I'm talking to the memory manager to give me space from the heap, and I want an array, right? And it says char bracket 1. I'm asking for 1 byte, right? Because I need to allocate space. I could say I get nothing there, but we'll see later on why we're doing this. So we're allocating 1 byte, and I'm getting a pointer back for that 1 byte, and I'm putting it into str. So now this is going to, where does this guy live, right? When I say string X, where does X live? Does X live on the runtime stack, right? Here's the runtime stack, right? Does X live over here? X lives over here, right? Here's X, right? But he's pointing over to here, right? So X is this string. Here's the length. The length is 0, and here's the pointer over here, and it's going to be pointing to an array of size 1 byte. But I want to initialize that, right? So I want to initialize that. So star str, it takes that pointer that came back from new and puts it in str. Here is str. It's pointing in, to where? Where's that pointing to? It's pointing to the array in the runtime stack, and it's being initialized to the null character, right? So why does it do this? Why is it initializing it to the null character? It goes over here, and this simply, right, what's in here? This is this is an array of size 1 byte. It's going to put this thing over there, right? That's what it's doing. What is this? This is what we saw. This is the null character, right? So this is the end of a string of length 0. Okay, because remember, we're talking about, this is before C++ introduced its own strings. So in C, strings were always character arrays terminated by a null. So if you have an empty string is a string. So it's a string with no information in it, but it has a null terminator. So that is what this default constructor does. Any questions about it? Is that good? So that's what's going to happen when I declare that I have I have a string and it's not, and I have to define an initializer. Okay, so far so good.
Wait, I have a question. Why can't you just do like string of like 0 equals the null character? Why are you using the pointer to reference it?
Why do I need a pointer to references? What do you mean?
Like, you see how you create string equals new char 1, right? And then on the line below it, you have using the pointer to initialize it. Can you just
Yeah.
initialize it just using like the
What would you
traditional
like
way?
me to- What would you like me to write?
No, I'm saying like, could you initialize it
Right,
using
right, right. Tell me,
string,
let's write it down so we can talk about it. What would you like me to write?
like I guess string,
This one is okay? That
0.
one, slow. This one's okay?
Yeah.
Okay, is this one, you want to change?
No,
What-
no,
what-
I'm saying, could you also do like string, 0 of like the array of 0 equals the null character?
Oh, what you want to do? Oh, that's excellent, excellent. What you want to do is instead, you want to say str sub 0 is equal to the null character. Is that what you want to do?
I mean, I'm saying like, why we're not doing that? I mean, I understand the pointer why.
Okay, that's very good. I'm not sure that you mean what I'm going to think you mean, but thank you very much. It's a very, very good question. So here is the question, right? Let me talk about this. Very, very good question. So I know that if I have if I say, give me a new integer, right? So we saw if IP was pointing to the integer, then I would simply say, star IP, we saw this before, gets a 10, right? So that's me put something in, and that's analogous to this thing, star str gets this character, right? This is a character, star str gets that. But let's say I have that whole array, right? I say, let's say I say like this. Int star A is equal to new int 100, right? So what does that mean? We saw the picture. So here is A. A lives over here, right? A is going to be a pointer to, let's say a pointer, let's say to an integer. When I say new int 100, the memory manager is going to find a place for 100 integers, right? And A is going to be pointing to the beginning of that, right? Now, if I would say something like, normally when I deal with arrays, I would say int A3, right? And I would initialize it to whatever I initialize it to. And I would say A sub 0 is equal to 15, right? And that would take me to the to the 0th element to put a 15. How do I access the elements of an array using the pointer, right? How do I do that? What's the equivalent of saying A sub 0? Because in fact, this array over here is really, it's a real array of 100 elements, right? And this is the 0th element, the first, the second, the third, and so on, right? How do I put a 15 in here? So the answer is, just like with an array that lives on the runtime stack, I use A sub 0 because that's right. Remember that A sub 0 is equal to 15. Why? But now we're much more sophisticated. We know why this works, because A sub 0 is just an example of syntactic sugar. A sub 0 really is treat A as a pointer plus, right, plus 0 dereferenced, right? It's all pointer stuff. So A sub 0 becomes this. A sub 1 becomes A, move over 1 of the size of an integer, dereference it to get a name, that's equal to 10, right? Likewise, when I get an array off of the heap, it's exactly the same thing. If I want to, so in this case, right, just this case over here, if I want to put a 10 into A sub 0, I also simply say A sub 0 is equal to 10. I use them exactly the same way. So whether or not my array comes off the runtime stack, or if the array comes off the heap, I use it in the same way, right? Now, why? Why does that work? And the answer is it works because the brackets, when you come at an array with brackets, it's really syntactic sugar. So in the case here as well, in the case of an array that lives in the heap, what is A? So A is a pointer to the first element. Well, that's exactly what A was over here, when it comes off the runtime stack. So when I say A sub 0 is equal to 10 for this guy, the guy who lives on the heap, the compiler does the same thing. I say A sub 0, it says A, which is that, right? The pointer lives in the runtime stack, but the actual array lives here, and it has a pointer to this thing here in the heap. So a sub 0 becomes a plus 0 dereferenced, and so it works. So I can therefore, just to summarize, I can use exactly the same notation, whether or not it comes off the runtime stack overheat. Now to go back to your question, I think what you said was, can I, instead of saying star, right, instead of saying star str gets that character, is a single character, right? Can I say str sub 0 gets that character, right, the null character? And the answer is absolutely, right? But which is better? It's better to do this, right? Because what's going to happen is the compiler is going to see, the compiler's going to optimize it away. But the compiler is going to see this. It's going to say, all right, let me take that pointer str, let me add a 0 to it, let me dereference it, and so on. And then I'm going to put the character in there. Here it directly says something that's this is machine language essentially. Dereferencing a pointer is basically done automatically in machine language. And so, and also this is more what programmers write. If I have a pointer and I will put something in the place that it's pointing to, I will use this notation as opposed to this notation. That said, we'll see this as well when we look at how things are implemented. So that was a long-winded explanation. I'm not sure, did I at least answer your question?
No, yeah, you definitely did. I was just being curious. That's why.
Right, no, but it's very, I really thank you. That's a very, very good question. All right, does everybody understand what I just said? That's very important. So what do we know now? We know now what pointers are. We know how the pointers work, and we know how when we go to the heap, we have these two verbs. We have new and delete, and they allow us access to creating and deleting memory in the heap. And we see how we can actually use it to create a string object, and write the default constructor to a string. Okay, so why do we do it like this? Because an empty string is a string, right? It just has no characters, but to make it a string, it has to have that terminator, right? So what this does is it allocates 1 byte, and that 1 byte is being used to the terminator. Any questions about this? Any questions about this? Is it completely clear?
Yep.
Okay, a number of people either fell off their chairs or whatever it is, because I see cameras pointing at the ceiling. But let's take another break, and we'll come back in 10 more minutes. Okay? See you soon.
Yep.
Yes.
Yes.
It is?
Yes.
Very good. I thought I clicked the right thing there. Okay, very good. So any questions about the default constructor? No. All right, very good. Now, what is a conversion constructor? I mean, know what a conversion constructor is? Well, first of all, let's look at the word, right? Conversion constructor, right? So what is it? It's a constructor, right? And again, what is a constructor? What does a constructor do? It constructs, right? It initializes. The conversion constructor initializes, because every constructor initializes the definition of constructor. But what is it for? So let's go back over here to the rational number class, right? So I want to be able to do, part of what I want to do with my rational numbers is I want them to really behave like numbers. And I want to be able to integrate the rationals, my fractions, into, into a normal, do arithmetic with them. So for example, I want to be able to say, look, I have, what are my rational numbers? X is a rational number, a half, right? And then Y, let's say, is a rational number 2/3, and then I have Z, right? So I want to be able to say that Z is going to be equal to X plus 1, right? Now, the only thing is, when we define operator plus down here, I'm defining my operator plus, the way that it's defined is very, very interesting. Let's take a look at this, and then we'll see what happens over here, and then I'm going to go back to the string class. So there are certain, in Java, right? If I define my own class in Java, and I have like objects, whatever they are, right? Let's say X and Y, those are Java objects. Can I say I want to be able to reuse this operator? I want to overload the operator that for my new objects. No, if I have, let's say I want to build a sort of, my own big integer class, say in Java, I would have to say something like X dot operator or something like that, or X dot add, right? X dot add and put add in my new class, whatever it is, and then say Y. Does that make sense to everybody? Because, and this is universal, right? This notion of if I have a class and X is a class, an object of that class, just like in a struct, I can use the dot operator to access the individual data members of my object in a struct, right? If X is a student, X dot name gets me to the name, attribute of that student, right? If I have a function and I want to call the function, I would say X dot whatever the function is on that object, right? That's the standard way of doing it. But in C++ and in other languages, like Python, for example, I can actually overload the operators. So in C++, I want to be able to say, let's say X is a rational number and Y is a rational number. I want to be able to say X plus 1, right? However, we had a name for this, right? We're overloading the operator, and it's sort of like a syntactic sugar, right? It lets my user do neat things instead of the sort of more cumbersome and less obvious way. Now, what would it really be? What would it really be? So let's say I can reuse. Let's say I can reuse this, right? So I would say something like X, right? That's a rational number. Let's say 1/2. And then I would have to say, I would define for my class, for my rational number class, I would say add, and that's to let me add something to X, and I would say X dot add Y. Does that make sense to everybody? Add would be the function name, and Y would be the operand that I'm adding to X. That's being the normal way. I would do Java like this and so on. Is that true? Everybody got that? It turns out that in C++, there's a bunch of names that I can use, and I can overload those names. And one of them is the operator that adds things, and it has a fixed name. Its name is operator plus, right? So I would say X dot operator plus, right? That's the name of the function that I can overload, Y, right? So if I want to define a function for adding, I can either call it add or I can call it operator plus. I can make operator plus do a phone call, but whatever it is, I can use this. I can use this name, this function name. I can overload the function name. The only nice thing here is that when I overload it, instead of saying operator plus Y, I can, because of the way C++ is defined, this will work, but so will this. And when I write this, the compiler does this. The compiler will translate this into X dot operator plus of Y. Does that make sense to everybody? Is that clear? Yeah. All right. So therefore, if we look at the operator plus, that's what's happening here, right? I have operator plus is being overloaded. It takes this parameter R, right? That's the Y that comes in, and then it defines whatever it defines, and and it returns a rat, right? Because that makes sense. If X is a rational number, it's a fraction, and Y is a fraction, then I want to add them and get a fraction, and it's going to return the fraction. Everybody understand that? Got that? Any questions? But I want to do more than this. I want to say X, which is a half, let's say, plus 1. Okay. Now here's the problem. What does plus mean? Well, plus, when I say plus for a rational number, it's going to call this function. It's going to call operator plus. Even though I can use this, it's going to translate into this. But if I look at the definition of operator plus, what's the right-hand side going to be? It's going to be a rat. You see that? X plus Y, Y must be a rat, because that's the way this function is defined. Right? It's a member function. It means it's going to be called on an X, right? On an object of the rational number type. And then it's going to call operator plus, right? But this thing has to be some kind of rat. Now, what's the problem? The problem is that that one is not a rat. Everybody see what the problem is? Anybody do not see what the problem is? Okay. So, but I want it to work. And the authors of C++ said, sometimes we want stuff like this to work. So what they have is the idea is I can have an operator, I can have a constructor that's going to take object of one type and make it into an object of that class type. So one clearly is not a rat, but a conversion constructor, it converts an object of some other type into the object of the class type of the class that you're talking about. So this class that we're looking at here is the rational number class. One is an integer. A conversion constructor is going to convert an integer into a rational number. So let's see what that looks like. Right, here's an example in this case here of the conversion constructor for the rational numbers. So and you have to understand, we said earlier that C++ wants to be helpful, right? So when it sees X plus integer, it says, can I do anything to make the plus work? And it says, yeah, well, if I can somehow convert that convert that one, the integer, into a rat, then I can use the plus operator for rats. So what would it mean? If I have an integer, right? Let's say an integer 5. What does 5 look like as a fraction? Well, clearly it looks like 5 over 1, right? 13 looks like 13 over 1, right? Whatever it is, 1 looks like 1 over 1. So if I write 1 and you want to convert it into a fraction, right? What you would do is you would put, let's say, 13 here and put a 1 over here. In general, if I want to convert the integer I into the fraction, I want to make the numerator to be I, right? And the denominator to be 1. So that's what happens over here. Numerator is equal to 1, to I, denominator is equal to 1. I get a rational number. So that's what happens when I say X plus 1, right? Before it does it, it says, okay, I have X, right? And that's going to be whatever, let's say, whatever it is, let's say 1/2, right? And I have a 1. I said, wait, hold on. I have to convert the 1 into a rational number. That's going to be 1 over 1. Now I can call operator plus, right? So on the left-hand side is going to be 1/2. A dot on the right-hand side is going to be operator plus, and I'm going to pass in, this newly constructed rat. Does that make sense to everybody? That's the idea. So that's what's happening over here as well. Let's say I want to, any questions? Anybody have any questions here? No questions? All right. So why over here would I need a conversion constructor? Why, when I'm talking about strings, would I want a conversion constructor? So let's say I make a string. Let's say I have a string X, right? And a string Y, right? I want to say the string X is equal to Y plus the C string, hello. Right? Now, what is this operator going to be? Well, we look through the list of operators, they're going to be concatenation, right? But concatenation is defined a string over here, a string over here, and I concatenate them, right? But this is a string class, this is an object of the string class type. This is an object of the string class type. So my concatenation has to work with string on the left and string on the right. In other words, this is going to become just like we saw in the rat class. This is going to become string, S1 dot operator plus of string 2. Okay, so in this case, the string 1, that's going to be y, but the string 2, that's going to be hello. But this is a C string, and operator concatenate, operator plus, is defined only to take these string objects and not C strings. So the answer here is the same as the answer was by the rational numbers. Let's make a conversion constructor to make this string, the C string, into a string object, and then this will work, right? We see the concept? That's what we want to do here. Any questions about what we want to do? No questions? Okay, so now let's see how we're going to do it. So before we actually look at the code, let's see what the code has to do. Let's see what the code has to do. It has to take this C string, hello, and make an equivalent string object. So where is that string object going to live? It's going to live over here in the heap, right? It has to live over here in the heap. So what's it going to look like? What's it going to look like? Well, it's going to have to, how big is hello? Hello, right? How much is that? Hello is 5. So I have to allocate how many? I have to allocate 6 positions. Why? Hello is 5, but remember a C string has a null terminator. So I have to allocate 6 bytes. Okay, so I got to, how am I going to do the allocation? Remember, I'm going to call new, and it's going to be with a bracket, right? Because this is going to be an array. And so hello is going to, and then I got to make this thing say hello, and have this turn the null terminator. And then I want to return the pointer, right, back where I found this. And what is the string hello going to look like? It's going to have a length of how much? A length of 5. Even though it uses 6 bytes, we don't count the null terminator as one of the, that's just a technical thing to make sure that we know where the end of the string is. But the actual length of the information that we need, it's only 5. And then we're going to have to return the pointer from new over here. And this is going to be somehow converted the C string into a string object. And so therefore, once I do that, then, S plus hello is going to work. Everybody got the idea? Any questions? What we have to do? Right, so let's see how we actually do it. Let's read the conversion construction. Okay, so the first thing we do is you're going to pass me a C string. You're going to pass me a pointer to hello, right? You're going to pass me the address of hello, and hello looks like it's a C string, right? So what I do now is I say, let's see, you gave me a pointer, right? You gave me a pointer to that string, right? It's called C string. That's the pointer that came into my conversion constructor. So what I want to do is I want to allocate space for that array in the heap, right? So how much space do I need? So first of all, I say char, because it's going to be an array of characters. How many? Well, I figure out the length of the C string, HELO, that's 5. How do I get the length? This is a built-in operation from C that's available in C++, string length. So string length is going to tell me 5, plus 1 is going to tell me 6. So now I have char of 6. Uh-oh. It almost made it all the way to the end. Right? Give me a second so I can find it. We lost it. Okay. Are you still with me, guys? You still there?
Yep.
Yeah.
Let me go bring it back. Just a few more minutes to do this. I'm waiting for one note to come back. One note is just sort of sitting there spinning its wheels. Oh, there we go. All right. Wow, very slow. Okay, can you see the string? Can you see the screen? Yes, no?
No.
No,
Loading up,
It's loading.
Oh, man. Okay.
so we can see it.
No, yeah.
yes.
Okay, good. So, all right, so when you pass in a pointer to hello, C string is gonna be 5. 5 plus 1 is gonna be 6. So it's gonna give you an array in the heap. How do I know it's in the heap? Because I say new. Basically, I'm saying, give me a new array of. Okay, we'll do this tomorrow, okay? Because it's not, we're out of time now, and hopefully we'll have better. But you understand the concept here? We'll pick up right over here tomorrow. Okay, any questions about this? Any
Yeah,
questions?
you're